Here we're given f of x equals negative 2x squared minus 4x plus 3. It's in messed up form. I know it's a second degree function. It's a quadratic function, they call it, because its highest power on x is the second power. I know it's going to graph as some kind of parabola. I just don't know where the vertex is or what it's going to look like because it's in this messed up form. So let's answer the question. We're going to get the standard form for part A. We're going to find the vertex, the x-intercept, and the y-intercept in part B, and then we're going to do a sketch in part C. So to get the standard form, we're going to complete the square and get the equation written in the form f of x equals a parenthesis x minus h squared plus k. So first we will isolate in parentheses anything that has an x in it. So we have f of x equals parenthesis negative 2x squared minus 4x in the parenthesis, and then close the parenthesis and put the plus 3 on the outside. Now we're going to carefully factor out the coefficient that's multiplying the x squared. Now we're not pulling out the greatest common factor. Be careful. We're just pulling out the coefficient of x squared, so we just have x to the second power with nothing in front of it. That means we have to pull out that negative 2, but if we pull it out for the first term, we have to pull it off for the second term also. So it leaves x squared positive 2x. Why is that? Because negative 2 times that positive 2x gives me a negative 4x in the back. And don't forget to bring down the plus 3. Now we're going to bring down the negative 2, bring down parenthesis x squared plus 2x. And we're going to add bracket 1/2 the coefficient that's multiplying x, which in this case is positive 2, close your bracket and square it. Then we're going to subtract the exact same thing, 1/2 times the coefficient of x, which is 2, close your bracket and square it. So we added and subtracted the same bracket term, which means we've done nothing to change anything here. We just are doing a little bit of hand waving. And then we don't forget the plus 3 on the outside. Okay, so bring down the negative 2, parenthesis, x squared plus 2x. Simplify, let's see. We're going to carefully pull out the subtracted bracket out to the back. Now the deal is this. There's a negative 2 factor in the front of parentheses, so anything we pull out comes out with a factor of negative 2 also. So bring out the minus factor of negative 2 times 1/2 times 2 in the bracket squared, and don't forget the plus 3. Now simplify inside the bracket only, so bring down the negative 2, parenthesis, x squared plus 2x plus in the bracket 1/2 of 2 is 1, close your bracket, square it, minus a minus 2 times 1 squared plus 3. Now make that double negative a positive and factor the first parenthesis. We're going to use the formula a squared plus 2ab plus b squared equals a plus b parenthesis squared. In this case, the a is the x and the b is the 1. So it's a plus b is x plus 1. Another way of remembering this is it factors at this point simply as x plus whatever's in the bracket, including the sign, positive 1 squared. Then double negative is a plus times 2 with a 2 plus a 3 at the end. So finally we get f of x equals negative 2 times x plus 1 squared plus 5. That is our standard form. Now it's easy to answer the next part with comparing our standard form to f of x equals a parenthesis x minus h squared plus k, because that implies that the vertex hk is, well, h is the number being subtracted from the x. That's negative 1 that's being subtracted from the x. And the k is the number added at the end of the equation. That's a 5 being added at the end of the equation. So when you make a very close inspection comparing the standard form and what we have, you can identify the h and the k and form the ordered pair for the vertex. Now for the x-intercept, we start by letting the y-coordinate equal 0 in the equation and solve for x. Now you can use our new improved version of the equation or the original, it doesn't matter. So let f of x, which is y, be 0, equals negative 2 parenthesis x plus 1 squared plus 5. Okay, move the 5 to the other side by subtracting. Then we'll divide both sides by the negative 2. So we have positive 5 halves equals x plus 1 parenthesis squared. Get rid of the square by taking plus or minus the square root of both sides. Turn it around too. Turn it backwards so the x is on the left. Equals plus or minus the square root of 5 over 2. And that is equal to, move the 1 over by subtracting 1 from both sides, you get -1 plus or minus the square root of 5/2. So that means that our x-intercepts are x equals -1 plus the square root of 5/2 comma 0. And also we have -1 minus the square root of 5/2 comma 0. And that's approximately equal to -2.60 and 0.60. That's going to help us do the graph. Okay, the y-intercept, let x equal 0 in either of the two equations, either the one they gave us or the one that we simplified, and solve for y. Well, we'll take our version. Y equals -2 times 0 plus 1 squared plus the 5. It simplifies to 3, so that gives us the ordered pair for the y-intercept. X is 0, comma, the y partner is 3. Okay, so we're going to use all this information to do this graph. The vertex is located at 1, 5, so we graph the point 1, 5. And you know you have an axis of symmetry, that a dotted line, a vertical line that goes right through that vertex to cut this thing in half. So you can draw that dotted line if you'd like at x equals -1. But there's our vertex at -1, 5. And then we'll draw our intercepts. We have an intercept on the y-axis at 0, 3, on the x-axis at -2.6 and 0.6, and we have the symmetry line, and that's our final picture.